Thank you so much. I hope you all are doing well. I'm Harshita Patel, Analytics Specialist, Solution Architect at AWS. Joining with me today is Yanzu Ji, who is the Product Manager at AWS, and Ganesh Kirti, who is the co-founder and CEO of TrustLogix, AWS partner. Working with customers across different verticals, what we hear is it's great that Amazon Redshift is providing price for performance and providing the scale that they need for their analytical workload. The ask was, can you help us simplify the management and creation of fine-grained security and access control for sensitive data? So in this session, working backwards from customer needs to provide that simplification and the control, we are going to dive you into the new security feature enhancements with Amazon Redshift today. Just with a quick show of hand, how many of you are already using Amazon Redshift? And how many of you are embarking your journey on Amazon Redshift? Excellent. So before we get started, we'll level set with what is the value of data and what we are hearing from the customers and their customer challenges. Then, based on the customer challenges, what are the key areas that Amazon Redshift is investing in? We'll look at the architecture that allows you the performance that you need for your workload, followed by inbuilt security features, and Yanzu will walk us through the new security features, and Ganesh will take us through the TrustLogix, who is AWS partner data governance use case. We'll wrap up with additional resources, and we will be available for Q&A outside the hall. So working with customers, the one common theme is every customer is looking to be data-driven. And why to be data-driven is because they want to gain the insight from their data. They want to tap into the value of the data to innovate their business, be more agile, as well as improve operational efficiency. But what are the key things that are required from an architecture, from a strategy perspective, to be data-driven? One is to integrate the data across different sources, coming at different volume, with different variety, different format at scale. Secondly, provide this data in the hands of end users in a secured fashion, on a timely basis, so they can take the data-driven decision at the right time. Secondly, because the data volume is increasing, because the business complexity is increasing, and the end user base who needs to consume that data for analytics is increasing, they need that elastic layer in their technology stack that enables them the performance. And all of these requirements, at the same time, make it cost effective. So working backwards from this customer, Amazon Redshift is investing in 3 areas. One, enabling the customers to analyze all the data, providing the performance and the scale that is needed for the workload, but with predictable cost. Thirdly, making it easy to use with out-of-the-box security and reliability. Let's dive into each of these pillars. So first is, you as a user for Amazon Redshift serving as your analytical data store, end users are accustomed to using the data visualization products, or maybe data science team is accustomed to using Jupyter notebooks, or even data integration products. With JDBC, ODBC, or Python connector, they can connect to Amazon Redshift. For data engineers, leveraging data API, if they are using any programming languages with supports Boto 3, they can do asynchronous processing with data API. With Amazon Redshift's integration with AWS native services, customers today have their data arriving on a data lake. They are also consuming the data for analytics from their operational data stores. So Amazon Redshift allows, from an end user perspective, a unified view. When an end user runs, say, a dashboard, portion of the data could be rendered from Amazon Redshift, portion of the data is coming from the data lake, and portion of the data could be from the federation through operational data stores. And not only limiting the end users to do discovery and analytics, but also providing the integration with Amazon SageMaker so that they can do prediction. The common ask from customers is they are curating the data, but they also want to collaborate with different departments without having to create data deduplication or without having to move that data. So this is the feature, data sharing, that Amazon Redshift provides. And then to innovate the customer's business, data sharing within Amazon Redshift integrates with AWS Marketplace Data Catalog, Data Exchange, which helps the customers to monetize their data. Let's take a look at from an architecture perspective. How does Amazon Redshift provide the performance that is needed at scale, be it the increase in data volume, be it the increase in business complexity, or the end user base? With the RA3 instance, it provides you separation of storage and compute, so you can size your compute based on your workload requirements. The capability of auto-scaling or concurrency scaling to allow you to handle unpredicted or spiky workload. Aqua, which is the innovation at the hardware layer, providing you hardware-accelerated cache for subset of queries, which can provide 10x the performance. And providing compilation as a service, serving as a cache, which caches the query segment compiled further to help you with the performance. Now, this separation of compute and storage becomes the foundation for data sharing. And with data sharing, you can provide workload isolation, or you can also collaborate within AWS accounts, across AWS accounts, and across AWS regions. And the integration with AWS Amazon S3 for your data lake. With the Spectrum fleet of compute node, which is completely an elastic layer, where it allows the end users to query the data in the data lake in any of the open formats, be it JSON, ORC, Parquet, or Avro. They can also join the data, which is on their Amazon Redshift data warehouse, to the data in the data lake. Finally, with the feature of federation, where they can do live query or run analytics on their operational data stores when they are on Amazon Aurora, RDS Postgres, or MySQL. And finally, integration with SageMaker Autopilot for prediction. The ask from the customers is also, it's great that Amazon Redshift provides this performance at scale, but how can it further help to simplify? And this is the launch of Amazon Redshift Serverless, which got launched today, which completely provides that ease, but learns the workload using machine learning model and auto-scales the compute that is needed for that workload automatically. So this completely simplifies the ease of use, where the business or the customers can focus on deriving the insights instead of specifying how many compute nodes or instances they need. And you pay as you go. With serverless, you get all the features that you get with the provision clusters, data sharing, federation, tapping into your data lake, ML, and all the rich functionality that are needed for analytics. Tens of thousands of customers across different verticals and segments are using Amazon Redshift to process and derive insights on exabyte scale data every day. But the key requirements for this customer is also stringent security. So with Amazon Redshift, the security is built in and also helps you jumpstart with your compliance. The first ask is, when they launch a Redshift provision cluster, or when they launch a serverless instance, customers completely control and they launch it within their own managed VPC. All of the security features that we are going to review, they are at no extra cost. So first is providing the customer complete control to launch the cluster or the serverless endpoint within their own VPC in their private subnet, as well as controlling the traffic by managing the security groups. The common ask from customers is also, we are using identity providers, for example, Microsoft, Azure Active Directory, Okta, or PingOne, where they are managing the users as well as the roles and the permissions. They want to use that, they want to have a central place to manage the passwords, the authentication, but they need the ability to integrate with Amazon Redshift, leveraging the same roles, the same users. So with Amazon Redshift, it integrates with identity access management to provide you single sign-on federation. One other ask from customers is provide multi-factor authentication. And also to simplify this integration with SAML 2.0 identity providers with Redshift. So we recently launched Amazon Redshift native identity provider for federation. Further, customers were asked asked, how can you help to simplify the database level permissions? So this is the recent launch to provide the customers the capability to use rollback access control. And today, to take it a step further, to enable the customers to provide row-level security, we have launched RLS today, which went GA. And Yanzu will walk us through in detail. The second ask is for customers who are in US, if they need to be Sarbanes-Oxley compliant, or they need auditability of the API call at the service level. Amazon Redshift integrates with CloudTrail to provide you that audit. They also have a need to do audit of the user activity, the connections, who logged in, who logged off from Amazon Redshift. So we recently announced the integration to provide the audit logs in AWS CloudWatch. This has significantly reduced the latency. In a matter of minutes, customers are able to review the logs as well as do near real-time monitoring. The common ask from customers is to have encryption of data at rest and encryption of data in transit. Amazon Redshift integrates with KMS, Key Management Service, where customers can also bring in their customer managed key to encrypt the cluster at rest. Serverless is encrypted by default, but you can also choose to bring in your key. I would like to highlight this one key feature that we have launched today. This is when customers who have stringent security requirement or to be compliant, they have a need to encrypt their provision clusters. Or when they want to tap into data sharing across accounts or across AWS region or integration with AWS Data Exchange, they have to encrypt the cluster. So with this announcement, providing you the capability to do faster encryption in matter of minutes compared to what it used to take days or hours depending upon the size of the data. So this is taking you from days and hours to encrypt your cluster in matter of minutes. And all of this, again, helps you jumpstart for your compliance. So let's dive into role-based access control. How does it enable you to simplify your database management permission? So with role-based access control, you create privileges, you assign those privileges to the roles, and you can assign roles to the users. You can assign multiple roles to the users, as well as you can also do role nesting. If you remember the previous implementation of groups, where you can assign groups to users, but it did not allow you to nest the groups. So with role-based access control, it allows you nesting. And the privileges, you can also take it a step down further. There are system privileges, for example, who gets access to create a user, who can analyze or truncate a table, and database or object level privileges, read access versus read-write access. So you can control the system privileges and object level permissions. Customers also asked, it's great that you provide super users and users, but we also need something in between to provide permissions to a database DBA or an operator. So with RBAC, out of the box, it provides 4 more roles at the admin level. For example, a security admin person has the permission to define the policies, but they don't need access to the table. A DBA can create objects, but does not need the super user privileges. So again, further, it helps you out of the box for security level roles. Let's take a look at this example. So RBAC is based on the principle of providing least permission. So in this example, role 1 has system privileges, it has object privileges, and then that role is assigned to user or n number of users. Based on the permission that is in this role, the user will only be able to perform those tasks. So again, based on the list permission model. So with RBAC, it helps you simplify your database permission management. And now, to control and protect your sensitive data, Amazon Redshift provides column-level access control, where again, based on the role, you can provide which role should have access to which columns. In this example, employee has access to column employee ID and name, versus the manager has access to employee ID, name, address, and phone. So you can control permission for your sensitive columns using column level access control. And now the key feature which we launched today, I'd like to invite Yanzu to walk us through. Thank you. Sorry.
Okay. Thanks, Hashida. And for the next, I will talk more details about role-level security. So I'm so excited to share that we announced the ability of the role-level security in Amazon Redshift today. With this release, Redshift customers can enforce the adequate grant access control to their data and govern who can access the certain rows of data based on the user profile. And by combining role-level security and the column-level access control, a granular access control model was achieved. So why we need role-level security? How role-level security can help Redshift customers to improve their security model. Tens of thousands Redshift customers use Redshift to run their data warehousing and get insight of their data. Customers are collecting and generating the new data more than ever before. The complexity and the growth of the new data brought us a new set of challenges. One of the challenges is to access control of the sensitive data. So there are three aspects our customer want. First, they want to filter the data within a table based on the level or geography locations. For example, an employee in a company can only access his own data, and his manager is supposed to access all the data under his department. And a CEO, he might can access all the data for his employees. So secondly, the customer want to restrict the access to a certain customer or a partner to their own data, not others. So thirdly, the customer want a simpler way and a scalable way to do the role access control. Before we have role-level security, the customer has to create new databases, schemas, or views to do the access control for a new customer come in. Apparently, it's not scalable because with data increasing, the complexity also increased as well. Given all the requirements from our customer and some potential opportunities, we develop role-level security based on role-based access control. In RS, we use an out-of-box role called SecAdmin, and SecAdmin can create RS policies and use RS policies to manage all the different kind of roles. By directly attach the RS policy to the roles, and then grant these roles to the user can finally get access to a table based on the permission they get. I want to highlight two things about this approach. First, we allow multiple RS policies assigned to the same user, and the user can be granted with the roles with multiple RS policy defined. And when there is conflict between these RS policies, we use AND logics and to do the operation. And that means the user can behave the least privilege. The second point I want to highlight is when RS is enabled on a table, and this table with no RS policy attached, that means this table is not accessible at all. That means that this table is protected by our RS. Now let's see an end-to-end example how this SecAdmin use RS policy to do the role-level control. We have a SecAdmin called Charlie, and Charlie created a policy called self-department only. By attaching this self-department only policy to the manager role and grant manager role to user Alice here, the Alice can access all the data under her department. On the contrary, the user Diane here, she didn't get the policy attached, and so she didn't get any privilege on these employee tables, and Diane cannot access any data on the employee table. And we have one more example shows how you can combine the RIS and column level access control to perform a granular access control method. The user Alice got 2 roles. One role as general manager role and give her the access to 3 columns: employee ID, name, and manager. And she, at the same time, she got another role called department manager role. This role gave user Alice the access for 3 roles with the employee ID 125, 126, and 130. By combining these 2 roles, and as a conclusion, user Alice can only access the record circles in this table. And above use case serves majority of our customers. But we still have customer ask, what if in my application, multiple users, they share the same username? How can we enforce different level role access for these users? Given this question, we introduced session context variables. You can define a runtime parameter to hold the current tenant context of your application. When different tenants log in, the username will be assigned accordingly. So you can look at the example on the screen that we have a tenant called Cardi, and when Cardi log in, we assign the username as Cardi automatically. And when RIS policy is created, it will pick up the username as Cardi and create the policy, RS. So when tenant Cardi log out, the username will be set free and it will be reassigned when next user come in. So this will facilitate migration for the customers they come from other data warehouse system. For the next, I will hand the topic to Ganesh to talk about the data access governance use case in Trust Logic.
Thank you, Anshu. Can you guys hear me okay? All right. Thank you. So I'm Ganesh Kirti. We are AWS partner. I'm going to talk about RLS, double click into RSS. Janchi just talked about few use cases. I'm going to double click into that, but I'm going to talk about that in the context of data access, entitlements, and governance in that context. Before I go into details, a little bit about Trust Logics. Arshida earlier talked about the complexity and data growth are bringing several challenges. So in the context of security and access, what we hear from customers is three primary challenges. So one is they would like to get their data consumers, get access to data much faster, but do that without breaking privacy and security policies of the businesses. The second one is the operational complexity. So we hear many customers use multiple Redshift instances. So one for dev, task, production, one for sharing with third parties, along with S3 and RDS several databases. So when you look at the managing the policies, access controls across all these different data environments, as the data is crawling across these environments, it brings in a lot of complexity. So that's the second challenge. The third one is the security teams in general, they work with business teams. They would like to collaborate with business people and data people to get them to do more with data. But they want to make sure that the risk to the business is mitigated the way the data is accessed. So they want to get visibility into who is accessing what, are they using the right policies, are the right policies being enforced consistently. So with that said, that's exactly what we are doing for customers. So TrustLogix is a cloud data security startup. So as I said, we are AWS partner. And what we do is the way we helping our customers is we deliver a data access governance platform as a service. And this service runs in AWS. And it's doing few things. One is it's tracking the data usage across these different data environments, including the multiple Redshift environments. It's looking for who is accessing data, is there any policy that is not effective, is there any data that is sensitive that is not protected. It's learning across all these different environments. Once it learns about the data access patterns, the second it does is it's now providing insights into different access patterns, any policies that are not effective, and then along with that, it's providing recommendations to reduce the data misuse as well as make the policies effective. So the third thing it's doing is providing fine-grained access controls and entitlements across these multiple data environments. And the way it does is it creates those policies natively where the data is sitting in. And then here are a set of, our customers use these different databases. They use our platform to secure data across all these platforms. Now I want to go into the RLS use cases. Yanchi already talked about several use cases. They're all very normal, and many customers have been looking for solving those use cases. And RLS is a critical capability from that perspective. And then I'll talk about a couple of use cases, where we see RLS is really going to solve those the use cases. So one is several companies we work with, especially in the financials verticals. In addition to financial other verticals as well, is they have Sarbanes-Oxley compliance, wherein they need to show evidence that any user, business users accessing the data, they are entitled to access that data, and then they have a purpose, and there is a business need for them to access that data, and then not more, not less, what they're entitled to access. So what happens is without RLS capability, typically what we see is they grant every entire table to these business users now that already are violating the compliance requirement there. That's one. The second is from the privacy perspective, these big data warehouses, they have a lot of privacy sensitive information. Some of these could be a GDPR compliant in the European cases, in other cases other privacy related regulations. So wherein you need to ensure that specific set of rows and columns as appropriate needs to be masked where appropriate. So without RLS, it's going to be very complex to implement those compliance privacy related, preserving the privacy of the data. The third one, another common one we see is without RLS capability, you usually end up granting multiple tables to these business users, and then that's where it gets the overly granted access to the data. So what that means is people have more access than what they need. That creates unnecessary blind spots and creates a data exfiltration threats, and it brings in additional risk to the business. So that's where the RLS capability really comes in. So I want to talk about before RLS is launched, how are we helping our customers, and then I'll talk about how it's simplified with RLS. So here is a use case, a specific business user. There is a business policy that says that there is a table called all trades table, and this table has data that belongs to multiple industry sectors. So this user, the policy says that only the financial sector is what's allowed for this user. So when this user runs the query on this table, only those two rows are supposed to be given to this user. So without RLS capability, this is going to be difficult to implement. So the way we did this was, as Angie was talking about, we had to implement the secure views, and then we had to implement custom UDFs, and then we had to secure the base table, create custom groups. It was very complex. That's one use case. The second use case is a little bit advanced than the previous one. Here is another common one we see with the many large-scale companies is, in addition to the regular access control policies, they have something called entitlements table. What this table is this table contains several business users, what they're allowed to access within the business. So these business users have different purposes and different reasons, different geographic boundaries when they need to access to data. So this table simply contains list of every user, what they're allowed to access. What I'm showing here is a very simple table. This table can be very, very complex. So the requirement in this case is when access controls are enforced, when someone is querying the data on the table, in addition to the regular access control policy, this entitlement tables has to be considered as part of the access control decision before the result sets are returned to the users. So now this entitlement tables is completely maintained. Users doesn't know about this table because this is a very security sensitive table. This is just sitting on the back of it. And this table is very dynamic. And typically the way this table is managed is through the custom workflows businesses own. And this table is constantly changing, and that's why it's very dynamic in nature. Now given this requirement, then here is, in this particular case, this user has only access to 2 client IDs. So here is the all trades table. The one that we highlighted in the green color is what this user is entitled to access. So this table contains the data that belongs to multiple clients, multiple industry sectors. Now when this user runs the query, he should only see these 2 client IDs that he's entitled to access. Now what's happening in the behind the scenes is very complex, the way we implemented it. We had to implement custom UDF functions that gets fired off whenever there is a query is run. And that UDF function is joining this entitlement tables that I showed before with this all trades table to give that result set that this user is allowed to access. So just to summarize, before RLS, we had to create custom secure views and then custom UDF functions. We had to create custom groups in some cases. We had to ensure that the base table itself is protected so that no one goes to table directly. And over the last few months, we partnered with Redshift team to natively integrate Redshift RLS capability into TrustLogic's data governance access platform. And then now with RLS, it is significantly simplified. So you just create a RLS policy, attach that policy to your table, and then you are done. So you start running the queries and the RLS will start getting enforced natively within Redshift. So this helped really significantly reduce the complexity. And in the entitlement use case, it's not only the performance, we had to make sure that there is no impact to the experience of users, but also there is a security aspect as well. So you need to make sure that by accident, no one is getting incorrect data as well. So there's a lot of maintenance and then constant changing. So all of that overhead is simplified. Now that this RLS is simplified, where does TrustLogix come in and help out our customers, right? In general, in a Redshift perspective, as I talked about, customers use Redshift for dev, Redshift for test, production, and sharing, multiple environments. As I mentioned about, customers tell us they would like to simplify creating access control policies, not just the access control policy at the RLS, but database level, table level, column level, entitlements I talked about. It can go very granular level access controls. They'd like to create these access controls across these multiple environments for these different data consumers. And these different data consumers have different purposes, different needs. There's a different regulations, different geographic boundaries. It could get very complex of creating these granular access control policies across all these environments. And that's where we come in. So now someone can go to TrustLogic's policy UI, and then they can create a simple policy without you needing to understand the code SQL grants to create those policies across all these environments. Just one simple UI, create a policy. Underneath, we map it out, we create the grants, and then push it out to Redshift. And there is a zero code policy here. In addition to provisioning the policies, right granular policies, we are also constantly monitoring who is accessing. It's just very important that you just don't stop with giving the access controls. Things are constantly changing. New data comes into your warehouses. The people change, their purpose change, their assignments change. So it doesn't mean that someone has access to data 3 months ago. They still need to have access to the data today, right? Because they might have done that project and they might have moved on. So we are constantly looking for who has access to what and then what they are doing. And then based on that, we identify overly granted access, any data misuse, any potential risks to the business, the way the data is accessed. And then we provide recommendations to ensure that the right sizing of policies are done so that there is always a least privileges when it comes to accessing the data. And then last but not least here is from the historic audit perspective, from the attestation perspective, from the compliance perspective, we provide reporting such as who has access to what they have been doing, You can look at what did someone did 3 months ago, 6 months ago. So you'll get access to all the historic reports. So I talked about very high level. If you'd like to learn more details, go to trustlogics.io website. With that, I'll hand it back to Anshu.
Okay, thanks, Ganesh. And for the next, I will talk about Amazon Redshift Native Identity Provider Federation. So this is a feature that we launched this year in April. It meets the customer use case that who want to access Amazon Redshift with their own identified provider. So our customer who use their own identity provider, such as Azure AD, they expect to integrate with Amazon Redshift natively by simply providing the username and password. They can access all the Amazon Redshift systems. And besides that, they also want to manage the user and group using the external IDP. So Redshift IDP Federation will serve above expectation very well. So let's get into the overview of this native IDP federation. Now you can see Azure ID now you can use Azure AD to authenticate access to Amazon Redshift, and the end user get their roles and the groups based on the role membership defined in Azure AD. The role level security rules defined Azure AD also can be seamlessly applied in Amazon Redshift as RS policies. To get started with the native Azure AD and Power BI integration, there are 3 steps. First, you can set up the Azure AD application, create database roles in Amazon Redshift, and grant privileges to them. Secondly, as an Amazon Redshift admin, you can register your Azure AD as an identity provider by run a simple SQL command. When an end user log in Amazon Redshift by authenticating in Azure AD, their group memberships will be automatically retrieved from Azure AD and being mapped to Amazon Redshift. The user will be authorized to perform tasks based on the privilege defined in Azure AD. The third step is you can use the native authentication with Microsoft Power BI and other applications using JDBC, ODBC drivers. Now you can see this is the architecture of Amazon Redshift Native IDP Federation. On the center of this graph is the Power BI tools, which can do the JDBC, ODBC configuration. For when a user come to Azure AD and provide their login credentials, the Azure AD will do the validation on these credentials, and they will issue a token. And the token was sent to the client and then passed to the Amazon Redshift. Once Amazon Redshift validate and identify this token natively, Redshift will authenticate this token, and then the user can perform the roles and the group user and the seamlessly in Amazon Redshift. So now user can start running the query. To learn more about this approach and more details, feel free to scan the QR code on the screen. For the next, I will talk about another exciting feature that we will coming soon in this following months. With this feature, it's called Fast Classic Resize. It solves many customers' pinpoint who has long wait time for encryption and classic resize. Also, it removes the restriction when customer conducts a classic resize, for example, the node number limit. Let's hear about our customer's voice. First thing we hear from the customer is encryption is very important to them. It's not only required on security, compliance, and data consumption, but also it's a military required when customer want to conduct a cross-region data sharing, or when they want to do the integration with AWS Data Exchange. Before we have fast cluster resize, customer has to go through the classic cluster resize technology to update the encryption change. And this can typically take few hours to few days depending on the customer's dataset size. During the resize process, the cluster will be read-only. Apparently, it cannot satisfy our customer who want their application to run the read or write operations very soon after the resize. So customer obsession is always our first priority. We introduced the fast cluster resize today to accelerate encryption and classic resize. Right now, you can process queries in minutes after you encrypt a cluster from an unencrypted cluster state. The read and write operation will be immediately available after the cluster is available. What's more, the same benefit can be applied to classic resize. The cluster can be available in minutes after the classic resize is done. And as I mentioned, the node number limit is removed when you restore a snapshot to a cluster. You can resize your cluster to any node number. We have a table on the screen here shows when the customer, we run an internal workbench test. It shows when customer resize a cluster, no matter the source cluster is RA3 or DC2 cluster, to a RA3 cluster. The performance of the cluster availability is improved by at least 86%. So if you want to try out this fast class resize or the encryption, you can just start in very soon. And you might ask, how can I get started? How can I pick the fastest path? Now I will show you on this diagram. So when you do the encryption change, ask yourself, you want an unencrypt to encrypt change, or you want to change your encryption key? If you just need an unencryption to encryption change, then you can simply go to the modify cluster path and change the state to encryption at there. It is supported via Redshift console, CLI, and API. And if you need encryption change, for example, from K1 to K2, you can go to the snapshot restore path. And this is supported via CLI and API. We have the console change will come very soon too. Okay. So for the next, I will pass the topic to Hashida to ramp up this session and introduce some resources you can refer to. Yeah.
Thank you so much, Yanzu. It was great to see these features which were announced today and shared. We do a private beta where customers like TrustLogic and our other customers were able to test it. It's great to see this launch and how it's enabling the customers. So if you want to learn and you are curious to learn more, we would like to share resources. Whether you are new to Amazon Redshift or an existing Redshift customer, Please refer to if you want to learn more about security and governance or Redshift resources. And all the features that we talked about, role-based access control, row-level security, native IDP integration, as well as the faster cluster resize, this blog, all of those blogs are available on the big data. And if you are embarking your journey on AWS, whether you are starting your journey or you're an experienced professional, please explore our training and certifications content. You can take a note of both of these QR codes. I'm going to move. So as was this session, as you can see, based on our customer feedback, we work backwards. Similarly, we would love to get your feedback for this session, and so that we can work backwards how to enable and improve your experience. But thank you all so much for joining this session. Thank you for your time. And please, we would love to get your feedback. Thank you.